Hi again. So welcome back in our video. So as a review, what we've done here last time is to do some lots of modifications here, lots of identifications here, and our goal is to make our all terms integrable. Okay, so our goal is to make our all terms integrable. So we have this first term, second term, and that is totally integrable independently. Okay, so that is our goal. Okay, so we need to do a lot of more modifications in our original or in our given DE. Okay, so in this topic here is very challenging since you need to uh, take some algebra, need to be familiarized in your or review your differentials, and you need to imagine or to think some ways in order for us to come up with this one. Okay, so let's have another example so that and say we have x squared y cubed x dy plus y dx plus dx is equal to 0. Okay, so as you've noticed, it's like our last example, but we have some uh, variables here. This part here is only x, and this part here is x squared y cubed. Okay, but we have this term here, x dy plus y dx, and as we say that this is the exact differential or equal to the derivative of xy. Okay, so we're gonna use this and change this as the derivative of xy is this part, right, is equal to this. So we identify this certain exact differentials, and then let's copy our remaining part, which is x squared y cubed plus d of x is equal to 0. Okay, so as you can see here, we have a differential of x and y and the differential of x, and we need to make this whole term here purely x and y xy alone and the x alone. Okay, so how can we modify this in order for us to later on do the integral as a part by part. Okay, how can we modify this new equation here, the equation 2. Say this is our equation 1, this new equation here is our equation 2. How can we modify this? Okay, since the differential xy, this part here, is present in our equation 2, then as we think, we must have a factor that is a function of product of x and y. Okay, wherein our exponent here must be numerically equal because x is raised to 1 and y is also raised to 1. Okay, because if we have that factor, then the process of integrating these two terms here will not affect the process of integration. Okay, so how can we can we make our both terms integrable? Okay, like what I have said, we have a function of x and y here. That's why we need to think of a function whose exponent is numerically the same, because x is raised to 1 and y is raised to 1. Okay, maybe later on you will understand what I am talking about. Okay, but say we in order for us to make our exponent here equal, then say let's try to multiply x to equation 2, and by doing that we have x squared y cubed dxy plus dx multiplied by x. So this is now our integrating factor, and if we multiply x, like what I am saying, that we need to make our this since we have a function of xy here whose exponent is the same, as you notice, by multiplying x we can now have the same exponent of x and y. Okay, so we have x cubed y cubed dxy. See, since the exponent of our xy here is the same, and we have also the same exponent of xy here, wherein we can write this as xy raised to 3, or xy cubed, right? So we have dxy, then our plus x dx. And as you notice, multiplying x by we only think of it, we only think of this variable, wherein we can satisfy our condition here that we must have a xy with the same component here multiplied by same component here, but not sacrificing our other term. Okay, since we need on this part naman, we need to make this purely variable of x alone. Okay, so by doing that, by choosing the variable x, I mean by choosing x to multiply on this equation makes this part. Okay, so we have xy cubed dxy plus x dx, and as you can see here, this, we forgot the equal 0. This equation 3 now, this is we can integrate both term from this equation 3. Okay, so by doing that, we have the integral of cube plus x dx. Okay, so let me start on this part so we are more familiar in this. So we have x d of x, wherein our x is raised to 1. Then by integrating, we have x 1 plus 1 is 2 all over 2, right? So going back on this part, we have xy and raised to 3. So we have xy 3 plus 1 is 4 all over 4. Okay, did you get it? And then our plus c. Okay, so all in all, our general solution for the given differential equation is this part, is xy y to the 4 all over 4 plus x squared all over 2 is equal to c. Okay, so that's it. Okay, once again, let's review. We have this as our given differential equation, ordinary differential equation. So we have x squared y cubed multiplied by this part, and we say that we are something like this exact differential of the x and y, and we make it the x and y, and then multiply by this part plus the remaining part, which is the x. And then we need to satisfy the condition that this this dy here, this term of dy here, we need to make it integrable. I mean the dxy here, we need to make it integrable, as well as the dx here need to make it integrable. So through thinking or through inspection, we see that if we multiply x, we can make the exponent of this xy equal, so that we can write in this form, right? So I have xy. And then we can also multiply the x in the other part, so this will not be sacrificed, wherein we can that is totally fine, because we can integrate this also in terms of variable x. Okay, so by having that, our next step is to integrate both terms and come up with this general solution. Okay, so you need to like what I have said, this topic here is very challenging, because you need to think, and through inspection you need to balance the equations to come up with terms that is integrable. Okay, so there's no exact formula. You need only to do some algebra and some modifications. Yeah, need to practice your calculus here. Okay, so thank you so much, and see you in the next video for more examples.